nutrients, energy from our food. And that leads us to the digestive system, which I have drawn on my driveway in sidewalk chalk. So we're going to go through the system piece by piece so that you understand the mechanical and chemical aspects of digestion. At the digestive tract, here it is. We have all the parts, and we're going to start from the top because that makes sense. So when you eat something, it enters your mouth, it goes down your esophagus into your stomach. So here's the stomach. There's a sphincter at the top of your stomach between the stomach and your esophagus called the sphincter. And that's just a muscle that keeps your stomach contents from going up your esophagus. At the bottom of your stomach, we have the pyloric valve, which similarly to the sphincter, keeps things from going where they shouldn't be going. So it keeps the stomach's contents from entering the small intestine until they are signaled to do so. And then it keeps things from backing up as well. So the orange is your small intestine. And you can see that it snakes all around, and that's because there's a lot of surface area in the small intestine. There's 250 square meters of small intestine, which is a lot. So the small intestine is doing quite a bit of absorption and digestion activity. And then finally, we have your large intestine, which goes up and around your small intestine. There it is, and then down to your anus. So the large intestine is otherwise known as the colon. When we're talking about the digestive system, we're going to start with the mouth because that's where your food goes first. And each part of the digestive tract has mechanical aspects of digestion and chemical aspects at work. Mechanical aspects mean using force to break things up, move things along. Chemical aspects could be things like using enzymes, acids, or bases to digest and break up food and into its various nutrient components. So in the mouth, we have mashing and moistening happening, and that's really through chewing, right? So we're chewing our food. We're adding saliva to soften and smooth food. If you've ever had like a dry mouth and tried to eat something, it can be actually kind of hard to swallow and get things down your esophagus. So adding saliva is one way that we can move things through more easily. Chemical aspects in the mouth, we have amylase, which is an enzyme in your saliva, and that begins starch breakdown or carbohydrate breakdown. Just starting it. It's not going to break down all the carbohydrates, it's just going to start. Then we have salivary lipase. Salivary lipase initiates fat digestion. So again, it's an enzyme. Any compound that ends in ASE is probably an enzyme. So when you have salivary lipase or amylase, those are enzymes, and enzymes are catalyzing reactions, and in this case they're catalyzing the breakdown of these macronutrients into their component parts. So you're breaking down carbohydrates into simple sugars, or what are called monosaccharides, and then you're breaking down fat into their fatty acid chains and components. We also have saliva that's washing the mouth out and neutralizing acids that might be in our food. So those are the things that are happening in our mouth. Then food travels down the esophagus and ends up in our stomachs. Mechanical aspects of digestion in our stomach. The big one is peristalsis, and peristalsis is like a wave-like contraction that pushes food from the top of the stomach to the bottom of the stomach. So the same type of action is happening as food moves down your esophagus. It's a wave-like contraction that's pushing food down your esophagus into your stomach, and then through your stomach into your small intestine. The stomach also is holding your food and mashing it into a paste, and it's able to hold your food because at the juncture between the stomach and the esophagus, there is a sphincter, which is a muscle that prevents contents from going back up the esophagus. When you have an issue with the sphincter, you can get acid reflux or what is called GERD. At the other end of the stomach, we have the pyloric valve. That's between the stomach and the small intestine, which keeps things from entering the small intestine until signaled to do so. So your stomach is like a big container where food is held until it's time to move along. And in your stomach, you're adding water to the food contents and you're creating what is called chyme. And chyme is just the result of the stomach's work, and it's fluid. So it's taking this kind of like mashed up, not dry, but pretty dry food mass that comes from your mouth. In your stomach, you're adding more water, more acid to that, and you're creating this kind of chyme. So you have more breakdown of the food and then addition of more liquid. So when food and nutrients leave your stomach to go to your small intestine, they're really in a pretty liquid form. Chemically in the stomach, we have the release of gastric juice. And gastric juice is basically hydrochloric acid. So it's this acidic liquid, and the acidity in your stomach activates a protein digesting enzyme called pepsin. And this means that most protein is digested in the stomach. And what's happening to protein is you're breaking down these larger protein structures into their component amino acids, which are the building blocks of protein and the form that we absorb protein through our digestive tract to be distributed to our cells. So pepsin is breaking down the protein structure into its component amino acids. And it's important to note that the mucus in the stomach protects it from hydrochloric acid or HCl. If we didn't have mucus lining our stomach, the stomach is a muscle, which means it's made up of protein. So it could actually start to digest itself, which would be completely undesirable. So the stomach has this mucus protecting it so that it can stay active and healthy. Once food leaves the stomach, it goes to your small intestine, where we still have this peristalsis going on, moving food throughout the small intestine. You can see how long the small intestine is. It's curled up. It's hugely long. So it is really a really big deal, especially in terms of absorbing your nutrients. But peristalsis is going to move things through the different parts of the small intestine. Chemically, we have hormones that signal for bile to be released from the gallbladder. And bile is important because it needs to emulsify the fat that we've eaten. This means that it needs to combine the fat with the more watery, fluidy chyme that the stomach has created. In the stomach, the fat kind of floats on top of the chyme. It's not really integrated into the whole mass because fat is hydrophobic. It doesn't like water, and chyme is pretty watery, liquidy. So you need an emulsifier to bring the two together. Think about salad dressing, where you have, until you shake it, you have oftentimes the oil on top and the vinegar on the bottom, and you really need to shake it together so you get both components mixed together. And that's what is happening when you emulsify fat. Hormones can also signal for pancreatic juice. And the pancreatic juice will contain bicarbonate, which is a base, and that will help to neutralize the stomach acid so that the small intestine is not dealing with such an acidic environment. Then you have pancreatic and intestinal enzymes that break down food into small pieces. And this is really taking your macronutrients and breaking them down into their component building blocks or parts. So you have carbohydrates and sugars, starches into simple sugars. That's going to be your monosaccharides, your glucose units. Protein is going to be broken down into amino acids, and then fat gets broken down into fatty acid chains. And then the walls of the small intestine have digestive enzymes for final food breakdown. So even as the macronutrient components are being absorbed across the small intestinal lining, you have enzymes in that lining to do final breakdown. And then the small pieces of the nutrients, the amino acids, the monosaccharides, the fatty acids are absorbed across these intestinal cells. So super important, the small intestine is the site of absorption in our body. There's other parts of the digestive system that are active in digestion, but the small intestine is where we absorb all of our nutrients and then they travel to our cells. The final part of the digestive system is your large intestine or your colon. And in your colon, we excrete fiber. This means that we poop fiber out. And you want to eat fiber so that your stool, your poop, is the right consistency. So you don't want it to be too loose, like diarrhea, and you don't want it to be too hard so that you get constipated. So fiber will help keep you regular, keep your poop so that it doesn't hurt you, and so that it's easy to move through. Chemical aspects in the large intestine, we have our gut microbiome here. And that means that we have all these bacteria living in our guts. A healthy gut has 100 trillion microbes, which is crazy, so many microbes. And these are good microbes, we want them. More and more we're seeing connections between the gut microbiome and other diseases. So you want to have a healthy gut microbiome, and your gut microbiome really likes fiber. Bacteria will feed on undigested carbohydrate. And you might think, oh no, why haven't I digested my carbohydrate? And this actually isn't a bad thing because fiber is a form of carbohydrate, but there are many fibers which we don't really digest that well. Think about corn. You can eat corn and it will look the same going in as it really looks going out. And you can even do a test on yourself if you want to know how long it takes things to transit through your digestive system. You can eat corn and then watch for it in your stool, and then you'll know how long it takes things to transit through your system. Fun little test. But bacteria are feeding on the undigested fiber that we eat, and they're also breaking down any remaining protein. And these are things that help keep the gut microbiome healthy, help keep our colons healthy, and help prevent us from developing digestive diseases. The colon will also resorb some water and some minerals. And this is pretty cool because you don't want a lot of water going through your colon or else you'll have diarrhea. So it's good to reabsorb it. And then your colon is pretty smart. So if you have, for example, a calcium deficiency, it will make sure that it gets every last bit of calcium back from the food that you eat. So if the small intestine missed the absorption of some calcium, the large intestine will make up for that if you have a deficiency. So it can kind of be responsive to bodily conditions, which is pretty cool. So that's the digestive tract from mouth to large intestine. It is really important in helping us get energy from the food we eat, breaking down the food we eat, and then absorbing across the small intestinal lining. And the small intestine is really well suited for absorption. The intestinal cells are going to absorb all the nutrients from the chyme that the stomach has created, and the small intestine is also selective, so it knows what nutrients are needed and it can adjust accordingly. So if it knows that you have an iron deficiency, it'll make sure to absorb as much iron as possible, for example. The small intestine has 250 square feet of surface area. That's so much surface area for absorption. It has this because of the way that its cells are shaped, and on its cells it has these like hair-like projections called microvilli, and that really increases the surface area of the small intestine so that it can absorb absolutely as much as possible. And then once you've absorbed your nutrients in the small intestine, your water-soluble nutrients will travel through the blood to be distributed to cells. So that's your simple sugars, your amino acids, your water-soluble vitamins, and your minerals. And then your fat-soluble nutrients are going to travel through the lymph system to be distributed to the cells. And those are things like your fatty acids and fat-soluble vitamins. So most important thing is that the majority of absorption happens in the small intestine, which is incredibly well suited for this task. Wondering what happens if you eat excess energy. So more energy, more calories than your body needs. Like, what do you do with those? Is your small intestine going to still absorb them? Yes. So your small intestine will absorb whatever it can. So if you're eating excess energy, you will absorb excess nutrients and energy, and you're going to store this energy in pretty much two ways. So you can store it as glycogen, and glycogen is just long chains of simple sugars or glucose, so long carbohydrate chains. There's two places we store glycogen. One is in our liver and one is in our muscles. But these two places have very limited capacity. So the liver stores a few hours worth of glycogen, so it'll hold you over like between meals. The muscles will store enough glycogen for their own function, but they're not really sharing with the rest of your body. So the majority of excess energy that we eat, once our glycogen stores have been filled, which happens relatively quickly, the majority of excess energy will be stored as fat. And fat cells have infinite capacity, so you can create new fat cells and then you can expand them quite a bit. So we can have many, many, many fat cells, infinite number of fat cells. And so we will store the majority of our excess energy, no matter if it's carbohydrate, protein, or fat. It will eventually be converted to fat and stored as fat. And we will go over all these conversions as we talk about the macronutrients. So each part of digestion we will talk about specifically for carbohydrate, protein, and fat in the weeks ahead. So you're going to learn more and more and more about digestion, but this is just an overview of digestion and then absorption.